Until this year, astronomers have relied on this circumstantial evidence to deduce almost everything that we know about black holes.
But all that changed just a few weeks ago with the first direct detection of not one, but two black holes.
It was these black holes that caused the gravitational waves in February's big announcement. Professor Sheila Rowan is one of the team behind the discovery. I joined her to find out more and to see what it all means for black hole science. It's a very exciting time to be talking about gravitational waves, but what exactly have we seen?
What we've seen is space vibrating, space shaking, as picked up by the LIGO observatories in the United States with a device that's about 4 kilometres long, measuring motions 1/10,000th the size of a proton in the nucleus of an atom. So quite phenomenal.
Wow, incredibly small.
This is the signal that we observed, and what we saw was those vibrations speeding up, vibrating faster and faster to a peak, and then the vibrations die down slightly.
And all of this detail, all of this vibration happens very, very quickly.
It does. It happens in about 0.2 of a second, but amazingly encoded in the vibrations in that 0.2 of a second is information about the source of those vibrations. Two black holes colliding about 1.3 billion light years away, so 1.3 billion years ago, and arriving with us here on Earth last September. And that speeding up is actually the two black holes spiralling in faster and faster until they eventually collide to form a new black hole that then wobbles at a particular frequency, and we can use that again to tell us about the properties of the new black hole that's been formed.
See, this is, to me as an astronomer, the really exciting thing, to be able to make an observation that tells you about the properties of the black hole itself, not about stuff falling into it, but actually about the black holes. So what do we know about the two that merged, and what do we know about the state of the system now?
We can tell the masses of the two black holes that merged, and one of them was about 36 times the mass of our Sun. The other one was about 29 times the mass of our Sun. The mass of that final black hole is about 62 times the mass of our Sun. If you add up the initial masses of the two black holes that merged in that final mass, you'll discover there's energy equivalent to 3 times the mass of our Sun that has gone somewhere, and where it's gone is into gravitational waves.
Wow.
In a short period, a huge amount of energy is produced, more than the luminosity, the light power of all the stars and galaxies in the observable universe.
Wow.
It's kind of amazing.
Okay, so what else do we know about this newly formed black hole?
We also know that it's spinning. It's spinning about 100 times a second. We know it's about the size of Iceland. It's not spherical, it's actually an ovoid. It's kind of squished in one direction, stretched in the other slightly, spinning away. So, and all of that we can get from this signal that we detect in gravitational waves. And this is the first time we've been able to do anything like that.
I think the most remarkable thing is not just the signal, but the fact that it represents a huge amount of effort by a lot of people, most of whom laboured for years without ever detecting anything. How does it feel to be sitting here describing a real signal?
It feels amazing, and it's the first time we've seen these binary systems. They might never have existed, and the black holes merging is the birth of a new black hole. That's a unique signature that we see, that we really couldn't see any other way, and so that's really fantastic.
This is incredibly exciting, but it's just one detection. So what's next?
It's just one detection, but we can combine that with our models for how the universe is, and that lets us calculate possible rates of these events, how many we might expect. I mean, it could be anything from a few a month to one a day. And so that's phenomenally exciting, that we may see a whole population of these events out in the universe.
And that's just from these two detectors?
That's just from these two detectors, that's right. These are just part of a whole potentially new astronomy, using a whole set of different instruments to detect gravitational waves across a wide range of frequencies. And that's very exciting.